LMS will be the first instrument from Southwest Research Institute to touch the surface of the moon, and also the first in a series of projects that the Institute has operating under the CLPS program. Our team at Southwest Research Institute, Aerospace Corporation, and NASA Goddard all contributed to this first extraterrestrial magnetotelluric measurement. The Lunar Magnetotelluric Sounder is a geophysical instrument designed to probe the moon's deep interior and provide new information on the structure and geological evolution of our companion world. Magnetotellurics is a mouthful. Magneto refers to magnetic fields, while telluric in general relates to the Earth. Geophysicists use it specifically as a reference to electrical currents that flow in the ground. And so magnetotelluric together means measuring magnetic and electric fields. The signals that we're looking at from the solar wind and the Earth's magnetosphere have frequencies that are way below what you might be familiar with as radio waves. These signals take minutes or even hours to complete a single cycle. The benefit of these very low frequency signals is that they penetrate deeply into the moon, and so they're sensitive to the moon's internal properties. This allows us to determine the temperature and composition of the interior of the moon. There are three main parts to LMS. The central electronics box was built by Southwest Research Institute. The magnetic fields are measured by a magnetometer that was built by NASA's Goddard Space Flight Center. The electric fields are measured between 4 probes that are deployed at 90-degree angles around the lander. These probes are sophisticated versions of those that you might use with a conventional voltmeter. Separations of about 100 feet are needed between the probes to detect a sufficiently large signal of the currents that are flowing in the ground. So we have to use a spring to launch out each of these probes to a distance of about 60 feet from the lander. These sensors and their launchers, as well as the magnetometer mast, were built by our colleagues at Aerospace Corporation. Although the moon is a relatively primitive body geologically, its arrested development provides insights into the early evolution of other rocky bodies like Venus, Earth, and Mars. Since the Apollo era, we understand that the moon most likely formed from a collision between the Earth and a Mars-sized protoplanet shortly after these bodies first formed. The moon then formed from the debris of this collision and was likely initially totally molten. As it cooled and solidified, internal layering developed in the moon's rocky mantle, but this layering may have been later partially or fully remixed in the interior. LMS will be among the first geophysical measurements to assess interior properties of the moon since Apollo. LMS is both simpler to operate and has better performance than these Apollo-era experiments. We hope that LMS, other geophysical instruments on this mission, and those that will follow on other robotic and crewed missions will determine the three-dimensional structure and evolution of the moon. Although the South Pole is central to the whole Artemis program for its contrasting sunlight and shadowed regions, the most profound geological contrast of the moon is between the near and far sides. The near side of the moon, and specifically the western near side of the moon, contains most of the maria. These are the lava-filled impact basins. They're the dark patches that you see, and that's how we see a man in the moon, among other shapes. For some reason, volcanism that followed formation of the lunar crust was not evenly distributed between the near and far sides. And the chemical composition of the crust on this western near side of the moon is also different from the rest of the moon. Yet, this is where most of the Apollo missions landed, and that leads us to question whether the Apollo results are representative of the whole moon, or are they different? The landing site, Mare Crisium, was selected to be outside of this anomalous region, away from the man in the moon, to enable LMS and LISTER to answer this question. LMS is the first of its kind instrument for planetary geophysics. Its demonstration paves the way for an even better version on a later CLPS mission, as well as opportunities for other worlds, including Mars.